Welcome to the Going Green podcast. Welcome to season 4. We've had a little break over Easter. Well, sort of a break. I was so busy. Holidays, my kids say to me, that's my students, did you have a good holiday, sir? And I'm thinking, no, I worked even harder than normal. Thank you very much. So, welcome to this new season. We celebrate with Earth Day, and unfortunately, we also celebrate Earth Day with a little bit of bad news. And that is that the amounts of, you got the wrong camera then, the amounts of CFCs, chlorofluorocarbons, which were basically a deal brokered in the Montreal Protocol of, ooh,
I'm going to say
1987. Yeah, I think it was about.
I thought it was 1994, but that might be a slightly different one.
Anyway, a long time ago, when we discovered this sort of ozone layer over Antarctica in the 80s, we decided what we would do is this wasn't a good idea, and we would phase out all the production of CFCs.
Now,
And
just to clarify what these CFCs were, these were actually used in refrigerants and those sort of things. So that's one of the things where the rise of the refrigerator, and the expansion of people wanting refrigerator caused the rise of having all these CFCs. And it was only until the first set of fridges were being, I wouldn't say recycled, but basically
broken up.
And disposed of. Of course, they take all the gases in the fridge that do the refrigeration, and basically they open them up and then let them out because that's the only way to dispose of them, really.
And they make their way up through the atmosphere, and when they get to the ozone layer, ozone is oxygen, not O2 but O3, and they interfere with this O3 and they convert it very nicely back to O2, and all is well. Except that means we don't have an ozone layer, and the function, as you probably know, of the ozone layer is to try to block out a lot of UV radiation. And if that UV radiation makes it to the Earth, then we're looking at a lot of people developing skin cancer. Cataracts is another feature that you can get from exposure to UV light.
I'm not sure feature is the right word in that regard. But
yeah,
yes.
yeah, I know what you mean. And so the discovery of these rising CFCs meant that we were going to have problems. So the Montreal Protocol, adopted in 1987, I looked it up.
All right.
And so the CFCs emissions should have dropped. And we've seen that happen. And people have been seeing the ozone layer starting to repair itself and all going well.
Wasn't there a few years ago where they said that the ozone cell had the hole, the CFCs caused a hole in the ozone down in Antarctica, and that's obviously how they're reporting it. And basically, they were reporting the hole was getting bigger and bigger and bigger, that it could reach Australia and sort of the south at the bottom. Is it the tip? Because it's sort of
depends which way's up.
Yeah, no, it would reach then the first land of South Africa and of course South America as well as Australia. So it was getting that big, very big, and so that's why it was the worry that the potential could cause lots of damage and cancer. And so what they've been reporting finally, like something daft, like only a couple of years ago, that the whole of the ozone layer, this is caused by the CFCs, has actually formed, and there was no more hole, if that makes any sense. There was full coverage of ozone across the south pole, which meant that was recovered and therefore deemed as a success for the Montreal Protocol.
Yeah, so the ozone layer was on the mend, lowering the risk of people developing skin cancer and cataracts, and they were looking at this to sort of be completely mended by about 2066. So
Yeah.
Great. Except now we're finding that the CFC emissions are rising once again. And the question is, perhaps, why? Now, let's tell you a little bit about CFCs. I'm not a great fan of CFCs. This is because they tried to kill me. Very quick story. I was in a computer room and the air conditioner broke and it released quite a lot of pounds of freon gas, a chlorofluorocarbon, into the room. And I discovered, later talking to the doctor, that a little bit makes you go high.
It's like a solvent high. We're talking that sort of.
Yeah, that type of high. And it's not very much either. A little bit more gives you motor paralysis, which is what I discovered because I came out of the room and said, I think I'm going to sit down. And that's the last I remember till I was in hospital. And people just said, yeah, you just hit the ground, mate. Because, yeah, I was having motor paralysis, and a little bit more gives you
Permanent paralysis.
permanent motor paralysis of everything. It's called death.
Yes.
So they're not nice things. And I was lucky. I had minimal exposure to these things and I recovered eventually. Some people say never, but yeah. And they're not nice things, but we're talking about not necessarily breathing in huge amounts like I tried to do, but we're looking at the effect on other things like the ozone layer. And we don't really want to get this stuff heading back there. Now, we're noticing in the air that these gases are starting to rise. And because the way the Earth spins, they're going to make their way to the poles. And, well, I don't know which one they're going to go for this time.
Well, the answer was, it was, as I said, the hole in the South Pole was detected. It wasn't say, it's all going down southwards. The answer was,
it's everywhere.
It was everywhere. It was in the north. It was just, there was, if you fly across the south, there was this whole dedicated actual zero ozone, as aka the hole, whereas over the north, there wasn't. There was still ozone left. That's why they said, but how much ozone wasn't very much. That's why we did all the protocol. Now, the more important thing is about this is actually technically the reliability or the accuracy of us measuring the CFCs in the atmosphere. Now, you might be saying, daftly saying, why are we detecting this sudden increase? And the answer is technically due to the fact that we're actually have better monitors, or we're accurately now measuring more to the smallest quantity, so we can get a very precise measurement of how much is around it. Because of course, we need to know those things so we can sort of see the balance. Because of course, if you're talking one bucket or another, you can't really say, well, how much a drop can make the difference. Yeah, so we're working now on the sort of drop size, and it's one of those big things where we are looking at it, we're monitoring it, because of course we need to know if the hole is going back and forwards, because it is a cycle. It's not it's either a hole is there or not. It takes time to make and build ozone, because that's a whole process of atmospheric chemistry. But that's just down the line. But people are saying, where are we measuring more CFCs is in there because we're having a very slight, small increase in production? Because of course we're allowed, or the Montreal Protocol allows for what is known as HCFCs, which is hydrochlorofluorocarbons, to be made. And subsequently, to make the hydrochlorofluorocarbons, so these HCFCs, a little bit of CFC needs to be made, so then you can make then the HCFCs. And that makes sense, and that's fair enough. And one of the things is that you can't be sure to convert all of it, and so a tiny little bit might be escaping inside the hydrochlorophores. So let's say you have 99.9% hydrochlorophores, but that 0.1 is a CFC. And that's allowed on the mod because it can't be that just happens to be chemistry. You can't do anything against that. And the point they're making is now we can detect that 0.1%, because apparently that 0.1% is all the difference it takes to actually change how much atmospheric ozone there is. And it's one of those awkward things to say, sort of, well, do we need to look back and say and reduce them? Because one of the things we're actually detecting is it's not all CFCs we're detecting out on the atmosphere. We're actually only detecting an increase in 5 of them. And they have some lovely names, as in chlorofluorocarbon, 112, then 113, 100, just different types and different numbers and things.
Rather than having horrible names for chemicals, they actually have given them nicer names. So, for example, CFC 11 is trichlorofluoromethane. And you can see it's a lot easier to say CFC 11 rather than that tongue twister of trichlorofluoromethane. And that's one of the easy ones.
Yeah, well, you don't want to say we've got 14A and 14B. Anyway, so we're detecting these 5 types of chlorofluorocarbons in the atmosphere, and it's one of those things where we don't know which specific one is doing all the damage, or if it is all one, or is it just a bunch of them causing the same amount of damage? Because of course, it's all the same mechanism. We can't tell, say, we've got 10% or 10% of the chlorofluorous is 14A and 0.1 is 14B. So therefore, we're looking at the manufacturer of, say, 14A or that process. The answer is, this is why we're looking at these things, to work out which is it, to determine and say, is it just we're making a lot of 14A and a 14B is being released because of, happens to be, and is it B that's causing damage, or is it all the A? And this is where we're still looking at it, still dealing and researching all these things. Like, we understood that this hole was making, so we determined to do it with the Montreal Protocol, but we still doesn't understand quite the relationship between this. So of the chlorofluorocarbons in the atmosphere, and how.
Let's also explain that the CFCs, chlorofluorocarbons, not just one chemical. There are, in fact, lots of them. And in fact, they're actually divided, I discovered when I was researching this, into 8 different groups.
Mm-hmm.
And there are some interesting ones. And I'm just going to read you a couple of facts of CFCs in group 1. And the important thing about these is the fact of their lifetime. And we've got from the well familiar of trichlorofluoromethane that I managed to get through, that lasts about 45 years. Now, that's actually something they call a half-life of about 45 years. And so it starts sort of dwindling, but it takes a long time to get rid of.
Which is why they say that sort of the ozone layer is going to be fixed by 2066.
That's doing these numbers.
They're doing these numbers and calculating the quantity. So,
but if you just base that on that one, well, then 2066 seems a good bet. But other chemicals have lifetimes of perhaps 100 or 190 years, or my favorite class 1, which is monochloropentafluoroethane.
Whoa.
Which is CFC 115, has a lifetime of 1,020 years. It's very stable, in other words.
Yeah, stable in the atmosphere, not so stable with ozone, yes. And you can see why this is where reporting on this, as in monitoring these and knowing where they are and what they're doing.
Because we're not fixing something now, we're fixing something for the next possible 1,000 years.
Yeah.
Right, okay. So then there's the group 2. I remember the group 2s. These were the halons. And I remember being in computer rooms and they had halon fire extinguishers. And one of the things that was good about them is they put the fire out. The second one was they had to have alarms and get everybody out first because it killed people. And I've been very grateful they've actually got rid of those sort of systems. Those chemicals only lasted sort of up to 65 years,
Oh, you casual 65.
only casually up to 65. And then we go on down through the other groups. And many of those chemicals, they don't give a lifetime for.
And that,
And this is for one of two reasons. Either their lifetime is exceedingly short, or usually their lifetime is basically indefinite. Once you've made this chemical, it stays.
yeah,
They are stable.
exactly. It's hard to say, it's this major problem in the world, or sort of, we've actually made something really good. Now we're, like plastics, we made some really good plastics early on. The problem is they will be with us for a very long time. So now we're having to find plastics that are actually biodegradable.
Yeah, in theory, not so good plastics, yet with technology, we've actually made them better because they do their job. And then when you put them into landfill, they basically are destroyed and aren't getting into the food chain.
Yeah. So, in relation to all these lovely CFCs running around in the atmosphere, let's actually look at sort of not where they're coming from, because obviously they're being emitted by the refrigeration, but sort of where roughly are they being detected and things. NORA, which is basically a weather sense satellite system, not quite a satellite system. It's atmospheric measurements. Uh, and they've been plotting around, basically going around the Pacific, as in they can go all the way up north, all the way down south in the Pacific. And basically, that's where their mission to monitor all the CFCs, because that monitors both the northern hemisphere. And basically, they've been detecting an increase in, I say production, increase in these CFCs in and around, I say China, but it's not formally directly towards China, because it, of course, is what is known as temperate East Asia and, of course, temperate West Asia, which, of course, counts as India. And so this is where they're detecting all these things coming out from. Is basically is the central temperate band of Asia.
Which are also the basically the industrial hub of the world, isn't it? If you think about where things are made, then India and China are the great manufacturing sort of countries of the world, which is why they've got very high pollution levels.
Yeah. And one of the other places that they were detected was actually coming and spewing out of the US, which is so surprising, because it's sort of, the theoretical opinion, you can understand that refrigerants are being made in China and India and those Asian countries, because, of course, they make a lot of fridges, and obviously that's what the refrigerants going for, all sorts of things. But why is America suddenly producing a lot of refrigerants? And the answer is, and it's unfortunate, is all these lovely heat pumps. Oh,
Yeah.
no. And the reason for that is because, of course, a heat pump is effectively a backwards fridge in relation to how it's transferring heat. But
And is set to become very, very popular in theory, according to our government here in the UK. Soon every house should have one.
and don't get me wrong, it's a technology that's great and wonderful, but of course it's still being used on a refrigerant to do all the processing of the heat exchange, and of course that requires refrigerant, and that refrigerant is being made apparently in America. It's one of those things. Who knows where it's actually being made in China or not? I'm just saying, but it's one of those things where it's just where they're spewing from and sort of where it's being made. And looking at these things, is that America doesn't have a big refrigerant, as in fridge making industry, but it does have a large heat pump making industry, which is of course using refrigerant. So yeah,
And, and in fairness, they are not using CFCs, are they? They are making other forms of refrigerant, but on the way to make these other forms of refrigerant, then CFCs may be involved.
yeah. So they're under the Montreal Protocol. They're allowed to make CFCs as an intermediate product, essentially, as in to help make other things like chlorofluorocarbons, hydrocarbon fluorocarbon, whatever, HCFCs. Well, you know, too many letters, too many names. And
Hydrochlorofluorocarbon.
there you go.
There we go.
And so, you know, they're allowed to make it, and they're allowed to make it. And one of the major things is that technically, in America, there is no federal restrictions on the amount of CFCs they're allowed to make, which seems daft because, of course, CFCs are banned, but they're not producing them.
Yeah.
Because, of course, they're making something else from them, but the chain of making it. So they're allowed to make unlimited intermediate CFCs, so long as all CFCs is processed into HCFCs. But
Yeah,
as we know,
because these HCFCs, which are hydrofluorocarbons, are basically partially hydrogenated cousins of the CFCs. So you make a chlorofluorocarbon and then you replace the chlorine with hydrogen. Now, as soon as you do that, these substances are not basically ozone damaging chemicals. And one of the things we talk about in damaging these things is how damaging. We compare most of them with CO2, and CO2 is sort of pretty bad, but we find that some of these are 40, 100, 1,000 times greater and more powerful than carbon dioxide, and they last just a little bit longer, quite, like up to 1,000 years. We've already talked on this show about methane being 40 times, but the chlorofluorocarbons many, many, many more times than that. So these hydrofluorocarbons are a good idea, but it's because we're making them from these chlorofluorocarbons. There, how about that?
yeah, it is this challenging thing to deal with. Is that we're working on making it better, but it's getting there. But any attempt to sort of fix it and any chance of badness is devastating. And so we're going to work on trying to make them less devastating, but that does take time. And we need the refrigerants, because, we need the refrigerants because, it's kind of what refrigerants are for. It's the whole point. And it's hard really to say, is it sort of as damaging as what they say they are in relation to, is it how much they are? Or is it just sort of, if one of them's out there, because it's forever, it's always trying to get it?
Well, the one that seems to be escaping at the moment, and the one they're monitoring, is this one called chlorotrifluoromethane, which is CFC 13. A lot easier to remember, CFC 13. And any idea, Paul, what is the lifetime of this chlorotrifluoromethane?
Do we know it?
Yes,
Oh.
unfortunately, we know it quite accurately. 640 years. So it's much worse than the one that was doing a lot of pollution earlier, which was the trichlorofluoromethane. You can see why they got horrible names, CFC 11. And CFC 11 had a life of 45 years, and that was what was causing most of the damage to the ozone layer. And now we're having just smaller amounts of this group 3 chemical, number 13, chlorotrifluoromethane, but that's got this lifetime of 640 years. So the small amount that we've put up there, that molecule is going around for the next 640 odd years, banging into any ozone molecule and splitting it back into oxygen. And it will continue to do that for the next 640 odd years.
Yeah, which is one of those bad things to say. Sort of how much pollution. You talk about pollution and sort of how damaging it is and all the landfills, but it is atmospheric pollution is very much damaging because it's the lifespan of these things. And one of the major points about doing these things is that, well, let's stop using them. All right, sure. Except, would you like
No
eh,
fridge.
firstly, no fridge. Yeah, not quite. But would you like your aluminium car, as in or whatever you make from aluminium? Because of course the
Planes.
huh?
Planes.
Planes, yeah, all sorts of things. Because they're talking about how an increase in the not plasma technology. That's the wrong way to put it, but a carrier of the gas used in
In,
plasma cutters
and plasma welding, yeah.
plasma welding, of course, is this very neutral, very non-reactive chemical CFC or HCFC.
HFC.
Yeah, okay, HFC. We'll get that. Too many letters. Is that they, you know, is that it's being used, and you tell me what could replace it, and the answer is so far they've looked and examined a lot of things, and the answer is nothing so far as yet.
So if they want to say, right, okay, get rid of your car, go on a bike, and then you realize that to actually manufacture that bike is actually got to put some of these chemicals into the air, into the atmosphere, then there's a little problem here that sort of, yes, you're now going to use your bike. You're not going to use as much CO2 from the car because you're not using the car. You are breathing a lot heavier, actually, probably putting out more of your own CO2. But if we look at the lifetime of the product and how much is actually made in the way of ozone damaging chemicals, which are going to cause climate change, then maybe welding a bicycle together could actually be worse than a car because the car is mild steel welded together.
Yes, which is
Weird, isn't it?
yeah, it's one of these odd things. Like for once, the car is better than the bike, which is hands in the air for Earth Day. Yes, and so it's one of these things where you need to be looking and be more informed about sort of where you're getting things from and how things are being made and what's being used, as opposed to just thinking, oh, I'm going to throw away use all my cardboard boxes and make a box fort or something. I don't know.
So we've come to Earth Day. There's not much to say about Earth Day, except to say there are quite a few events going on. Companies are reiterating what they're doing to try and be good, and that's quite good. But the worry that we've got at the moment is to celebrate Earth Day, we're looking at a rise in CFCs. So we thought we'd bring this to your attention when you next see some things advertising what you can do on Earth Day. Just have a think about some of the consequences of these either chlorofluorocarbons or the hydrofluorocarbons that are supposed to replace them. Thank you very much for listening to the Going Green podcast. We hope to be back next week with more on climate change that's happening near you. Until then, it's goodbye from me.
And a goodbye from me.
Bye-bye.
Bye.